Welcome. In this session, we will take a look at the second derivative test. The second derivative test is another way of determining if a given critical value is a relative maximum or a relative minimum. The advantage of this is that it looks at the value of the second derivative at a single number. The disadvantage is, one, you have to find the second derivative, and two, it may not work. So the reason is how we actually use the second derivative test. So let's first look at the statement. Suppose that C is a critical value of f. If f double prime is positive, then f has a relative minimum. And if f double prime is negative, f has a relative maximum. One way to think about this is in terms of concavity. If f double prime is positive, f is concave up, so it lies above its tangent. At C, a critical value, f must have a horizontal tangent. It must have a tangent because if f double prime exists, so does f prime. And if the graph is above a horizontal tangent, that means it's above the value at the point of horizontal tangent. So that point must be a relative minimum. And the reverse happens if f double prime is negative. So the second disadvantage I referred to is that if f double prime is 0, or if f double prime does not exist, then this doesn't tell us what happens. In such cases, we have to fall back on the first derivative test. If you have a fractional exponent in f, it's likely that you will have a critical value where f prime doesn't exist. That means f double prime will not exist either. So in such cases, obviously second derivative test is not going to work. The second problem is, how do we tell if second derivative is 0 without evaluating it? Of course, in general we cannot, but if you factor f prime completely in order to determine the critical value, if you see any exponent bigger than 1, then you are going to have critical values where f double prime is 0. And the first issue is that f double prime might be hard to calculate. So I would recommend that you use second derivative test mostly for polynomials. And those are the only kind of examples I'm going to do. Our first example is something where we kind of done the problem, but we will do this using second derivative test, so you can compare it to using the first derivative test. This is x cubed minus 3x squared minus 9x plus 11. It's easy enough to redo, so we can just find the derivative. That will be 3x squared minus 6x minus 9. It factors as 3 times x minus 3 times x plus 1. So the critical values are 3 and negative 1. Note that f prime is always defined, so we don't have to worry about critical values where f prime doesn't exist. The second derivative can also be done by using the power rule. It's 6x minus 6. F double prime at 3 is 12, that's positive. So 3 is a relative minimum. At negative 1, f double prime is negative 12. Since f double prime is negative at negative 1, that's a relative maximum.